Hello everyone. In this video we're going to be solving an exponential equation. We have x to the power x squared equals 2 to the power 1024. So let's start by writing the exponent 1024 as a power of 2. You probably know 1024 equals 2 to the 10th power. It's kind of easy to remember because it contains a 10 in it. So if you know some powers of 2, you can just expand and get to this answer as well. So we're going to go ahead and break this down. X to the power x squared can be written as 2 to the power 2 to the power 10. Now, wouldn't it be nice if x was 2 and x squared was 2 to the 10th? But that's not the case. So we kind of have to manipulate this until we get a point. Until we get to a point where the base and the exponents are going to work with x and x squared. So we can kind of write this as 2 to the power 2 times 2 to the 9th, and then we can kind of put these two inside, like 2 to the 2nd to the power 2 to the 9th. But again, we have the same situation. This number, when squared, is not going to give us 2 to the 9th power. So it's still not there yet. Let's manipulate a little bit more. So I can kind of write this as like 2 to the power 2 to the power 10. Can also be written as 2 to the power 2 to the 2nd times 2 to the 8th. And now I can go ahead and separate this part. So I can write this as 2 to the power 2 to the power 2 to the power 2 to the 8th. And 2 to the 2nd power is 4. So we can write this as 2 to the 4th to the power 2 to the 8th. Great. Now we know that 2 to the 8th power is 2 to the 4th power squared. Nice. So we can safely say that, hey, if x is equal to this, then x squared will equal to that, and we'll be good to go. Awesome. So in other words, x equals 16 is a solution. All right. So here's the $1,000,000 question. Can negative 16 also be a solution? X equals negative 16. Is that a solution? Let's go ahead and check. So the original problem was x to the power x squared, but we could also use a modified version. But let's go ahead and check the original one anyways. So if x is equal to negative 16, we get negative 16 to the power negative 16 squared. And that is 256. And now, since we have a negative base and an even exponent, this is going to turn into a positive number. We can write this as 16 to the power 256, and that is 2 to the power 1024, because 16 is 2 to the 4th, and if you multiply 256 by 4, you're going to get 1024. So negative 16 also works. We have two solutions. So we could also approach this problem a little differently by using ln. I don't know if we're going to call it a second approach, but let's just take a look. We could ln both sides and then get the following. Bring this down, x squared ln x equals 1024 ln 2. So again, we kind of need to manipulate this. 1024 can be factored, like 2 to the 10th power times ln 2. And then we can kind of break it down like 2 to the 8th times 2 to the 2nd times ln 2. And write it equal to x squared ln x. Here we can move this to the front, but that's going to give us a very large number here and a smaller number here. So that's not a good idea. So we kind of need to do the opposite and move this one instead, the smaller one. And that's going to give us the following, something similar to what we did. X squared ln x equals 2 to the 8th times ln 2 to the power 4. And as you can see here, if x squared is 2 to the 8th, then x is 2 to the 4th, and we are good. Okay, so x equals 16 works. But negative 16 is not allowed here, so we kind of have to use an absolute value, or just consider the fact that the exponent is always even, so we can have a negative base. Make sense? Okay, but you don't get that directly from the ln function because it's all because of its domain. Great, so here's another question. Is 2 to the power 1024, is that a big, large number? Let's find out. So according to Desmos, it is undefined. Well, this number probably too big for Desmos, maybe, I don't know, but it just calls it undefined. But let's go ahead and take a look at Wolfram Alpha, and that gives you actually the exact value. This number has a lot of digits. It actually has 309 decimal digits. Such a gigantic number, which you will never need, just for fun. But if you know that log 2 is about 0.3, then this shouldn't be too hard to estimate. So that's a very big, large number with 309 decimal digits. Let's go ahead and take a look at the graph and we'll finish up. I wanted to give you two graphs here so that you can compare. The pink one is y equals x to the power x squared, which is kind of above. And the bottom one, the blue one, is y equals x to the power x. Notice that x to the power x squared behaves a little differently, like it curves differently. And, in terms of concavity and all that stuff, it's slightly different. But they kind of behave the same way. And like earlier, like before, the Desmos calls this undefined. But the answer is -16 and 16 to our original equation, which was x to the power x squared equals 2 to the power 1024. And this brings us to the end of this video. Thank you for watching. I hope you enjoyed it. Please let me know. Don't forget to comment, like, and subscribe. I'll see you tomorrow with another video. Until then, be safe, take care, and bye-bye.